Assalamualaikum, and today we are going to learn chapter 7, rotation of a rigid body. In this chapter, cover rotational kinematics. At the end of this chapter, students should be able to A. Define and use angular displacement, 2 Roman average angular velocity, instantaneous angular velocity, average angular acceleration, and the 5th Roman instantaneous angular acceleration. For B, relate parameters in rotational motion with their corresponding quantities in linear motion. And C, solve problems related to the rotational motion with the constant angular acceleration. What is rigid body? A rigid body is any object whose change in shape and size is very small when exerted by a large force. It is body that does not deform under influence of forces. For example, a piece of iron in a rigid body, not a loaf of bread. Right now, we proceed with 7.1 rotational kinematics. Under 7.1.1, angular displacement symbol theta is defined as an angle through which a point or line has been rotated in a specific direction about specific axis. The SI unit for angular displacement is radian. Figure 7.1 shows a speedometer needle rotating counterclockwise about fixed axis through a point O. The coordinate theta shown in the figure specifies that the rotational position of the rigid body is given at instant. Okay, now we proceed with figure 7.12. An angle theta is subtended by an arc length S on a circle of radius r. Given equation S equals to r theta. Okay, this is equation S equals to r theta, where theta is angle, which is angular displacement in radian. Refer here, this is our theta or angular displacement. S is called arc length. S is called arc length, and R is the radius of the circle. R is the radius of circle. Other unit for angular displacement is degree and revolution. Using conversion factor, 1 revolution or 1 rotation equals to 2 pi radian, which is equals to 360 degree. Right now, we proceed with angular velocity. Okay, we start with average angular velocity, symbol omega average. Average angular velocity is defined as the rate of change of angular displacement. Equation given, omega average or average angular velocity equals to angular displacement final angular displacement minus initial angular displacement divided by T final minus T initial, or equals to the rate of change of angular displacement. Every part of a rigid body has the same angular velocity. Right now, we proceed with instantaneous angular velocity, symbol omega. Is defined as the instantaneous rate of change of angular displacement. Equation given as follow. So, omega equals to d theta dt. So, we did differentiate equation angular displacement. So, by differentiate equation angular displacement, so we can find instantaneous angular velocity. It is a vector quantity. The SI unit for angular velocity is radian per second. Others unit is revolution per minute. Sometimes we note as revolution per minute or RPM. Next, the conversion factor, 1 revolution per minute. How to change 1 revolution per minute to radian per second. So 1 revolution over 1 minute times, by using conversion factor, 2 pi radian equals to 1 revolution. Next, 1 minute equals to 60 seconds. So we can cancel out revolution, minute, minute, and the final unit is radian per second. So the angular velocity can be positive or negative, depend on the direction of the body is rotating. The direction of the angular velocity. Okay, how to determine the direction of the angular velocity? This direction can be determined by using right hand grip rule, where our thumb refer to the direction of the angular velocity. Our curl finger is refer to the direction of rotation. Figure 7.14 and 7.15 show the right hand grip rule for determine the direction of the angular velocity. So our curl finger show the direction of rotation and show the direction of the rotation. So by using right hand grip rule, our thumbs is refer to the direction of angular velocity. Next, refer to figure 7.15. Our curl finger now is directed anti-clockwise. Okay, so our thumb is show the direction of angular velocity. Okay, now we proceed with 7.13, angular acceleration. When angular velocity of a rigid body change, it has an angular acceleration. Okay, average angular acceleration, symbol alpha average, is defined as the rate of change of angular velocity. Average angular acceleration equals to omega angular velocity final minus angular velocity initial divided by t final minus t initial, or equals to the rate of change of angular velocity. Next, we focus on instantaneous angular acceleration. Symbol alpha is defined as the instantaneous rate of change of angular velocity. Alpha is equals to formula for instantaneous angular acceleration. Alpha is equals to limit from the 30 to 0, the change of angular velocity divided by change of time, equals to d omega dt, which is we need to differentiate equation angular velocity respective to t. So after differentiate equation angular velocity, so we can find our instantaneous angular acceleration. Is a vector quantity. The unit of angular acceleration, the SI unit of angular acceleration is radian per second square. Note, if the angular acceleration alpha is positive, means the angular velocity is increasing. If the angular acceleration alpha is negative, then the angular velocity omega is decreasing. Means our motion is slowing down. The direction of the angular acceleration, if the rotation is speeding up, alpha and omega is in the same direction. Alpha and omega is in the same direction. Right now, by refer figure 0.7.17, our rotation is slowing down. Means our alpha and omega is in opposite direction. And by using right hand grip rule, our curve finger now is directed anti-clockwise. My thumb is directed upward, but our rotation is slowing down. So alpha angular acceleration is in opposite direction. In opposite direction. Means our rotation is slowing down.